Git is a version control system. That means it is a tool that tracks every change made to a set of files over time. If you write code, modify a configuration file, or update a script, Git records what changed, when it changed, and who made the change. This history is stored in a structure called a repository. A repository is simply a folder that Git is watching and managing. Why does this matter in the context of a secure delivery pipeline? Because every automated pipeline, whether it runs security scans, builds an application, or deploys software, starts with a single trigger, a change pushed to a Git repository. Git is literally the starting point of everything that follows. When a developer commits new code and pushes it to a shared repository, this action can automatically launch a chain of verifications, static code analysis, dependency checks, automated tests, container image builds, and deployments. Without Git, there is no reliable way to coordinate this chain. Before diving deeper, let us clarify a few essential concepts that you absolutely need to understand. The first concept is the commit. A commit is a snapshot of your files at a specific moment in time. When you make a commit, Git saves the state of all tracked files and attaches a message describing what was changed. Think of a commit like a save point in a video game. If something breaks later, you can go back to a previous commit and restore a working state. Each commit is identified by a unique identifier called a hash, which is a long string of letters and numbers, for example, A3F5D92B1C4E67890ABC. This hash is generated automatically and guarantees that two different commits can never have the same identifier. The second concept is the branch. A branch is an independent line of development. By default, a Git repository starts with one main branch, often called main or master. Developers can create new branches to work on a feature or a bug fix without touching the main branch. For example, if a developer wants to add a new login feature, they create a branch called feature/login, make their changes there, and when the work is ready and reviewed, they merge it back into the main branch. This approach protects the main branch from being broken by incomplete or untested work. The third concept is the merge. A merge is the operation of combining changes from one branch into another. When a feature branch is finished, it is merged into the main branch. Git tries to automatically combine the changes, but if two developers modified the same line of code in different ways, a conflict occurs. Conflicts must be resolved manually before the merge can complete. The fourth concept is the remote repository. A remote repository is a version of your repository hosted on a server, accessible to your entire team. Platforms like GitHub, GitLab, and Bitbucket provide hosting for remote repositories. Developers push their local commits to the remote repository to share their work, and they pull changes from it to receive updates made by their colleagues. Now, let us talk about the commands that make Git work in practice. You do not need to memorize every command at this stage, but you need to understand the logic behind each step. The command git init creates a new local repository in your current folder. It is the starting point when you begin a new project from scratch. The command git clone followed by a remote repository address downloads a complete copy of that repository to your machine. For example, if you want to work on an existing project hosted on GitLab, you clone its repository to get all the files and the complete history. The command git add tells Git which changes you want to include in your next commit. You can add individual files or all changed files at once. This step is called staging. The command git commit saves the staged changes as a new commit in your local repository. You must include a message describing what you changed, for example, git commit m add input validation to login form. The command git push sends your local commits to the remote repository so others can see your work and so that any automated pipeline can be triggered. The command git pull downloads the latest changes from the remote repository and merges them into your current local branch. This keeps your local copies synchronized with the team's work. The command git status shows you which files have been modified, which are staged for the next commit, and which are not tracked by Git at all. It is a very useful command to understand what is happening in your working directory at any moment. Now let us connect all of this directly to the secure pipeline you have already studied. In the workshops and quizzes you completed earlier, you saw how a pipeline can include checkpoints, stages where code is automatically scanned for vulnerabilities, where dependencies are checked for known security issues, where tests are run to verify that nothing is broken. All of these stages are defined in configuration files stored inside the Git repository itself. On platforms like GitLab, this file is called gitlabc.yml. On GitHub, it lives inside a folder called github/workflows. This file describes the pipeline, what steps to run, in what order, and under what conditions. For example, a typical secure pipeline configuration might say, every time code is pushed to the main branch, run the static analysis tool, then run the unit tests, then build the application, and only deploy if all previous steps passed. This entire logic is written as text in a file tracked by Git. That means the pipeline itself is versioned, audited, and can be reviewed just like any other piece of code. This concept is called infrastructure as code or pipeline as code, and it is a cornerstone of the DevSecOps approach. When the pipeline configuration is stored in Git, you can see exactly who changed the pipeline, when they changed it, and what they changed. If someone disables a security scan by accident or on purpose, that change is visible in the Git history. This creates accountability and traceability, which are essential properties in a security-conscious environment. Let us also talk about the concept of a pull request or merge request. These two terms refer to the same thing: a formal request to merge one branch into another. On GitHub, it is called a pull request. On GitLab, it is called a merge request. The important thing is what happens during this process. Before the merge is accepted, the team can review the code changes, leave comments, request corrections, and run automated checks. Automated pipeline stages can be triggered automatically when a merge request is created, so that static security scans and tests run before any code is ever merged into the main branch. This is a critical security checkpoint. Vulnerabilities are caught before they reach the shared codebase, not after. A concrete example to make this tangible. Imagine a developer on your team writes a new API endpoint that directly inserts user input into a database query without sanitizing it first. This is a classic injection vulnerability. If your pipeline includes a static analysis tool configured to detect this kind of pattern, the tool will flag the issue when the developer opens a merge request. The merge will be blocked until the vulnerability is fixed. Without Git and without the pipeline triggered by Git events, this check would either never happen or would have to be done manually, which is unreliable at scale. Another important point is the concept of tags. A tag in Git is a label applied to a specific commit to mark it as significant, for example as a release version. Tagging a commit as version 2.0.0 allows the team to always know exactly which state of the code corresponds to which version of the application deployed in production. In a security context, this is valuable. If a vulnerability is discovered in production, you can quickly identify which exact version of the code is affected and trace it back to the commits that introduced the problem. Finally, let us address the notion of access control on Git repositories. Not everyone should be able to push code directly to the main branch. Most teams configure their repositories so that only approved and reviewed code can be merged into protected branches. Direct pushes to the main branch are blocked, and all changes must go through a merge request with at least one reviewer. This is a security practice at the organizational level, enforced through Git platform settings. It reduces the risk of unauthorized or unreviewed code reaching production. To summarize the essential points of this introduction, Git is a version control system that tracks every change to your files over time. A repository stores the complete history of all commits. A commit is a timestamp snapshot of your files with a descriptive message. Branches allow parallel lines of development without affecting the main codebase. A merge request or pull request is the gateway through which code enters the main branch, and it is the ideal moment to run automated security checks. The pipeline configuration file lives inside the Git repository, making the pipeline itself versioned and auditable. Tags mark specific versions of the code, enabling precise traceability. Access control on branches is a security measure that prevents unauthorized code from reaching production. In the broader context of your training, Git is not just a developer tool. It is the foundation on which the entire secure delivery chain rests. Every scan, every test, every deployment begins with a Git event. Understanding how Git works at this high level is essential before you can understand how to secure, audit, and automate the pipeline that sits on top of it.